36.1% Ca, calcium.
Yeah, and 63.9%.
This is for empirical.
This is empirical formula. Yeah. So then it is a problem that says a compound is 36.1% calcium and 63.9% chlorine. What's the empirical formula? So what do we do first? Well, convert it to grams first and then moles, right? So grams first. Let's just imagine now. We could imagine that this is like 50-gram sample. We could imagine that's a 200-gram sample if we wanted to, but we just need to get some grams put down here so then we can convert it into moles. So I'm going to make it easy for us. I'm going to say, let's just imagine we have a 100-gram sample. So here, if we have a 100-gram sample, then that turns these percentages into grams, just like this. Yeah?
For example, if you gave us the percentage one on the test, and then you said, but it's not like 100, it'd be like out of 50, you would just divide it by 2.
Yeah, you could do that. Yeah, that's fine.
Okay.
Yeah. We just need to get it into grams. That's the point where, as soon as we get into grams, then we can go into moles and see the ratios there. So then you said the next step is to go into moles. That's right. So how do we convert the calcium into moles? Oops, I almost get
1 mole of calcium.
Yeah, 1 mole of calcium.
Over the mole of acid calcium.
Which is?
It's 40.07.
40.07. That's it?
8.
8. Thanks.
Or is that a 6?
Okay. And we do the same thing for chlorine. I believe chlorine's mass is something like 35 point something. 453. Yeah. Okay, so if we do this, what's the answer? 36.1 divided by 40.078. What is that? I'd like you to be typing this stuff in just so we can make sure that we don't make any calculator errors here. Because, believe me, calculator errors slip in. This should be 0.09 or 0.9. We got 366.01 moles of calcium. And this, let's see, it's 63.9 divided by 1.80. Good. That's what I got too. 1.80. And you can just see, you can look at this and say, oh, well, this is getting pretty clear here. We can see that this is going to be twice as much as this. But let's just divide both of them by the smallest amount. So I'm going to divide both of them by the 0.901. And what do we get for our ratio here? The top one is 1, and this one's 2. So the final empirical formula is going to be CaCl2. Now, what if I ask you a really weird question, like, what's the name of this formula?
Sodium chloride. Calcium chloride.
Calcium chloride, that's right. This is calcium chloride.
You're going to be on the test?
Oh my god, what if I ask that?
I'm gonna
And
like
then I
cry.
fail.
I'm just going to have my head explode. No! Calcium chloride, this is an ionic bond. You know what an ionic bond is. You don't?
Oh, now you're gonna say, is it an
I
ionic bond? or
swear we learned this. Like,
Metal.
ionic is what? I'm sorry, Maddie. Then we get, yeah? Metal, non-metal. And so it's just a regular naming like this. It's not monocalcium dichloride. It's just calcium chloride. You wouldn't say mono anyway. That's right, yeah. So what was your question?
Why does it come out, like, I did it on the calculator when I was doing the packet, and it came out as 2. It doesn't make any sense, but not instead of 1.
It comes out as 2? This comes out as 2?
Yeah, it comes out as, like, exactly 2.
Yeah, it should be. We're just talking about, think about it, if you think about what's really going on here, we're converting these into the numbers of atoms, but we do it in big chunks, like in moles. So this is still a big number of atoms here. So if you have twice as many of these atoms as those, then it should make sense that the formula is just CaCl2. It should be twice as many of those. It should be exactly twice as many too.
But with the numbers, I don't think it makes sense. It's like it's 1.80 divided by 9 for no 1. Does that make a difference?
This one right here?
Yeah.
It makes a small amount of difference, but we round, we just make it a general kind of like, we get to the closest whole number, really, basically, that's what we're doing. Yeah.
Well, that chart that like multiplies
Now that's not going to be given. That's not going to be given. Now this is one of the easier problems right here, because it's very clear this is a 1 and that's a 2, right? But what if, just what if, we would have gotten a different ratio here? What if this ratio would be 2.5? Oh man! What do we do?
It would be 2.5.
You multiply
It'll be
by 2 by
CA2.
2.
You multiply both of these numbers by 2.
CA2.
So you multiply this by 2 and you multiply that by 2.
It'd be 1 and 2 and 5.
So then this would be 2, overall would be 2, and this would be 5. So the overall formula would be Ca2 Cl5. Yeah. What about if this number was not 0.5 but something else? What if it was 0.75? I don't want to see you rounding up to 3 here.
Times it by 3. 4. By 4.
By 4. Multiply it by 4. What will you get if you multiply this thing by 4?
8. 9.
8, 9,
2 times 7, 5.
5.
5. I got 5 too.
11.
We need 5.
11. Is it 11?
It'll be 11.
It'd be 11.
It's 11, yeah. So this would be 11, and this would be times 4, this would be 4. So this would be Ca4, Cl11.
You can't, like, what if it was 4 and 12? Could you make it, like, 3 and...
If it was 4 and 12, you'd have to simplify it.
You can?
Would you get more?
Yeah, but it wouldn't ever be anything more than the lowest ratio anyway.
Wait, but if you don't simplify it, you get marked off.
Yeah, because it is an empirical formula. It has to be in its most reduced form.
Is there like I guess like a conversion for everything? So like if it's like 0.25, is there something?
It's multiplied by what?
4.
4. There's only a certain amount of waypoints, and those waypoints you have in that chart over there is 0.25, so if something turns out to be 0.25, then you multiply by 4. If it's 0.333 repeating, then you multiply by 3. If it's 0.5, then you multiply by 2. If it's 0.67,
What
or
if it's
very close.
0.4?
Well, if it's 0.4, then it's in the middle, right here. For our
If it's 0.4,
problems,
then you just write,
for
so
our
if it's
hold on,
2.4, then you just do 2.
if it's for our problems, the 0.4. If you get a 0.4, then that means you've done something wrong, because all the problems are designed so they either hit one of these things or exactly 0.001 or 0.00 or 0.999, whatever. Okay, so it should be very, very, very obvious to you. It'll hit one of these points, whatever those ratios are over there. Okay, so if you get a 0.4, or if you get like a 0.61, or if you get a 0.89, then that means you're doing something wrong, because I don't design any of the problems to have those kinds of numbers come out. Those are the weird ratios. They do happen in real life, but it's a little bit more. Those are a little bit more complicated. I won't have you guys do those. I could do that, but I'm not going to. Okay? Pretty simple. Okay, that's an empirical problem, empirical formula problem. Another thing I could do to make it more difficult would be to not give you this percentage. I say 36.1% is calcium, and the rest is chlorine. So but that's easy though, right? Yeah, you just have to subtract by 100.
Wait, is there any other, like, difficult way you can give it to us? Not difficult, like...
I can give you a total amount of grams and say, here's this many grams, here's that many grams, and the rest is whatever. So you just take the difference and figure out what the rest is.
We can have
And you
Yeah,
can
we can
assume
have
that it's out of 100 grams.
For the percentage, always, yeah,
But
make
what
it easy
about-
on yourself.
Oh, I know, but you gave us.
These are really,
Is there a chance
really
that you're
easy.
going to be like, it's 250 grams with it, and like 15% of it is this, and the rest is that?
I'm not going to give you a two-variable equation to solve. Don't worry, it'll be fine. It'll be an easy starting point. It's just to figure out who knows what they're really doing and who doesn't. So if you know what you're really doing, there's only a certain amount of questions I can ask you. And those of you who don't know what you're doing, you're going to get it wrong anyway. So that extra little step won't really matter.
So we go over the quiz questions that we did.
Yes, I like that quiz question. I like that a lot. The last one, actually. Last quiz question. I like that one a lot.
Did we get that correct?
Yeah, you should have. 6.2.
For the next topic, can you go over a question from the quiz?
That's what we're going to do right now.
Oh.
If you watch us, it'll be funny because we just said that. It's okay.
Not bad.
It's okay. It's okay. It's okay. Huh? It's recorded, yeah. So I need to usually. Who got this correct?
Not me.
I got it.
Hell no.
If I find the right paper. Oh, I got it correct.
I got it. Yeah, that's good.
Yeah, me too.
All right. Oh, I was so happy that I made a little 100 with a smiley face underneath it. Oh. So, number. Oh, no, that's not the right one. I'm talking about 6.2. 6.2.
So is it, oh, it's a different one?
It's a different one, slightly different one.
Alright.
Oh, percent.
All right. Okay, so it depends on which version you got. You might have slightly different numbers.
Which one are you reading?
I'm looking from version A, 6.2A.
With number 4, they both have the same.
Oh, that's right. Yeah, they do. Oh. Okay, so number 4 doesn't matter which version you got. You're still going to get the same numbers. So Al reacts with CuSO4, also known as aluminum. Aluminum reacts with CuSO4. That sentence,
I thought Al was a name.
it is a name, but it's also
Yeah,
aluminum.
I thought it was like Al.
Al who?
Al Gore.
Al.
Oh
Yes, I know. That first sentence has a lot of information in it. That first sentence says Al, aluminum, is the limiting reactant. And it's also reacting with CuSO4. It's the limiting. So you don't need to do any extra limiting reactant problem with this one. Okay? It says if you start with 1.85 grams of aluminum in the reaction, and the percentage yield is the percent yield of Cu is 56.6%. What's the mass of Cu that is actually produced? Actually produced. And it says to start the problem, first balance the equation below. First, let's just balance this, and then we're going to diagram what this question is really asking us. Because I think that's the hardest part of this question, is just figuring out what it wants. So let's do this. It's Al plus CuSO4. And that gives you, what does that give you? It gives you Cu plus Al2 SO4 3.
They didn't balance it correctly.
All right.
Oh, it's not that.
How do you balance it, Adon?
Oh, did we balance this already or no?
Let's balance it. Come on.
Okay. You do 2.
Yeah.
3, 1.
Yeah. Good.
How did I do that?
Very nice. You don't have to put that one there. I just do it to make sure that I know that I've covered it already. Okay.
That's fine.
So that's very good. You've been practicing, haven't you? Or did you just look at your sheet?
Wait, I swear to God, I actually did it right now.
Nice. All right. Good. It says it start off with 1.85 grams of Al. So let's do that. Let's say 1.85 grams. Right there, we know that that is the limiting reactant. That's the limiting reactant. So that's going to determine the theoretical yield of our product over there. We also know something else. We know something very important. We know that the percent yield of Cu, so Cu's percent yield, that equals 56.6%. So 2 huge pieces of information. And then it asks us, what does it ask us? It says how much is actually produced. So we need to know what the actual yield is. We don't know what that is yet. Yes? Okay.